Now this question is on energy. You have a car of 500 kg is at rest at point X. Now happens to be at rest, so you cannot always assume the highest point is at rest. Alright, so but in this case, yes, no initial speed, so no KE initially. Then the car's brake are released and the car rolls down the slope with its engine off. As it goes down, you know that it will go faster and faster, accelerate, and the speed at the bottom at Y here is 11 meter per second. All right, so and it actually there's a drop in height, vertical height of 30 meters. So the question asks, what is the energy dissipated by the frictional force when the car moves from X to Y? All right, definitely to solve this, we have to use conservation of energy. Now, let's make it very simple, assuming there is no friction. So, total energy at point X is equals to total energy at point Y because of conservation of energy. So, what's the total energy at point X? So, because it's at rest, there's no KE. All right, not because it's at the highest point. Okay, so you really have to pay attention to the question. So what you have here is only GPE due to its height from the reference ground over here. There's a height of 30 meters. Now let's consider at Y. At Y here, and as I mentioned, let's assume there's no friction. So almost everyone will know that all the energy it has will be kinetic energy because there's no height at this reference ground here. Height is considered 0. All right. But then because there is frictional force, all right, there's frictional force. So that means to say that the amount of KE will be lesser because some of the energy from the GPE, okay, will be wasted in the form of internal energy, your heat, and also the propagation of mechanical sound wave, okay, heat and sound. So I should put the work done against friction over here, and it's supposed to be a plus. Because total energy, the KE plus the work done against friction, then that is equals to the loss in the GPE. All right. So assuming if there's no, you should know that if there's no friction, the car will not be at 11 meter per second. It will be higher. The fact that because there's friction, it slows the car down a little bit. That's why it goes to 11. All right. If you understand that, you just need to plug in the formulas. Okay, so this is mgh, and this will be your half mv square and plus work done against friction. Now this question is easier because they just want the energy dissipated by the friction, which is that's what you want to find. There's no need for you to open up the formula force times distance. All right, so you just need to sub in the value. The mass is 500 times gravitational field strength 10 times the height, which is 30 meter, equals to the half times 5000 times the speed, which is 11 square, plus the work done against friction. All right, so you can just solve this simple math. So the work done against friction will be 119750 joules, and if you round it off to 2 sig fig, that will be the answer, and then change to standard form. Since the options are all in standard form, I jump 5 times, so there will be 1.2 times 10 to the power 5 joules. So that's how you solve the question. So the only key thing that that you have to be mindful is the work done against friction. Okay, the energy dissipated by the frictional force is on the right hand side. Some of you may prefer to see it this way. I mean, up to you as long as you understand. So the GPE here minus the work done because of the friction, then that is equals to KE. So if you choose, if you can understand this better, you can go ahead and do it. It's just up to you as long as the concept is correct. All right, thank you.